Okay, so the cool thing about these problems is we're going to actually tell you what to find. We're going to tell you that you want to find the x-intercept. So you just have to remember that x-intercept is y equals 0. So 0 equals x squared minus 7x, or sorry, 6x minus 7. I can factor that, so 0 equals x minus 7, x plus 1. So x equals 7 and negative 1. Can put those on my graph. Can write them as points if I want. 2, 3, 4, 5, 6, 7. I'm going to throw them straight on my graph. Okay, let's try to find the y-intercept. So x equals 0, so I'll have y equals 0 squared minus 6 times 0 minus 7. Y equals negative 7. Okay, so now I need to find a vertex. Again, the vertex is just a midpoint, so I'm just going to go ahead and, or the x-coordinate of my vertex is just a midpoint. The x-coordinate of the vertex is the same thing as x-axis symmetry. So I'm just going to average 7 plus negative 1 over 2, 6 over 2, so 3. So my axis of symmetry should be x equals 3, meaning I'm going to have a symmetrical, or a line, axis is a line, that my parabola is going to be symmetrical down. That also means that my x-coordinate vertex has to be on that line. It's the midpoint. I don't know the y, so I'm going to sub it in. I know my x is 3. My y, if I sub it in, I'll get 9 minus 6 times 3 is 18. Okay, 18, negative 9. Minus 7 is negative 16. So my vertex is way the heck down here somewhere. We'll call that negative 16. So now I should be able to draw my graph. And I'm not good at drawing graphs. If you can't notice, I'm really bad at actually hitting points, so we're just going to make that point bigger. Okay, I'm usually going to want you to find a few more things. I'm going to want you to find domain, range, and if it has a min, or if it has a max. Min and max are probably the most easiest to see. You're looking to see if it just, does it have a minimum point, up or down? So if I look at this, this does have a minimum point. It never gets past this negative 16. That is the lowest that this thing ever gets to. It doesn't have a maximum. These arrows here means that it keeps going. So it never gets to any sort of max. So this has a min, and the lowest it ever gets to is negative 16. So that is my min. That's it. Okay, domain and range go in alphabetical order. Domain is your x's, range is your y's, and you're just trying to say, what x's does this hit, or what y's does this hit? So if I look at my domain, it hits, and by hit, it doesn't mean on the x-axis. It just means, is that x part of a point on this graph? So 3 is obviously part of a point on this graph. It's 3, negative 16. 4 would be part of a point on this graph. It would come down here, by before negative 15 maybe. 5 would be part of a point. 6 would be part of a point. Anything up to 7 is obviously part of a point, and even going more. 8 would be part of a point. It'd be probably up there somewhere. 9 would be even higher, maybe up here. 10 would be even higher, but it's still going to be part of a point. So nothing is going to stop any of my x's, because I can do the exact same thing going the other way, from being part of this graph. So my domain actually hits all my x's. Negative infinity to infinity. And I'm going to use parentheses with that. Range, look at my y's. Going down, negative 1 is part of a point, it's part of 2 points. Negative 2 is part of 2 points. Everything is part of 2 points until I get to negative 16. Negative 16 is only 1 point, and below negative 16 it's not even part of the graph. So my y does have a stopping point. My stopping point is negative 16. Going up, though, again, because of these arrows, it means it's going all the way up. So any y going up is going to be part of a point. So I'll go up again to infinity. Now I used a bracket with negative 16. The bracket actually means that it hits that point. It's a hard stop. So the bracket means it's a hard stop. It actually hits it. Parentheses means it gets close to it, but it never actually hits it. Since infinity is an idea, it can't actually ever hit infinity. So we always use parentheses with infinity. Okay, so let's go ahead and look at another one then. Say we have y equals x squared minus 5x minus 3. So the first thing I want to do, again, I'll be told what to find, is find my x-intercept. To find my x-intercept, I let y equals 0. So if I do that, I'll get 0 equals x squared minus 5x minus 3. And I look at this and then I go, heck, this is not factorable. Oh no, what do I do? Well, I know two other ways to solve these by now. I can solve them using quadratic formula or completing a square. I'll do quadratic formula for this one. So quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a, and that equals x. That gives you your x. So I'll sub in. I will get negative b's. Negative 5 is 5 plus or minus square root of b squared, so negative 5 squared is 25 minus 4 times 1 times negative 3. Oh, I guess I could have done that in my head, but I already started writing it out, so I guess I'll write it out. Over 2 times 1 is 2. Continue figuring this out. 5 plus or minus 25 plus 12 is 37 over 2. Okay, this is what x equals. This is 2 points. This is 5 plus square root of 37 over 2 and 5 minus square root of 37 over 2. This is hard to graph. I do not know what 5 plus square root of 37 over 2 is. I could estimate it. Square root of 37 is near 36, so sure, maybe that's near 6. But it's still hard to graph. Heck, let's move on and just go to the other stuff. So y-intercept, x equals 0. That one's much easier. Y equals 0 squared minus 5 times 0 minus 3. So, negative 3. Graph that. Great. Vertex and axis symmetry. I do the same thing. Again, I just average them, right? Well, I can average this. So let's go ahead and try to find my axis of symmetry. So if I do that, I have two things. I have 5 plus square root of 37 over 2 and 5 minus square root of 37 over 2. So average them means add together and divide by 2. So we'll add them together and divide by 2. Well, if I add these together, my square roots actually cancel out. So I just get 10 over 2 divided by 2, which would be 10 over 2 is 5, so 5 over 2. So my axis of symmetry is x equals 5 over 2. Okay, so that would be what, about 2.5, I guess? So I will guess it is. It's 2.5. My axis of symmetry is there, meaning my vertex, the x-coordinate of my vertex is 2.5 or 5 over 2. I'm going to stick with fractions. I just need to sub it in to find my y. So let's go ahead and sub it in. Okay, so I'm just going to sub it in, and if I do, I'll get y equals 5 halves squared minus 5 times 5 halves minus 3. I should be able to do this. 5 halves squared should give me 25 over 4. Minus 5 times 5 halves would be minus 25 over 2. Minus 3, find a common denominator. So I'll get 25 over 4 minus 50 over 4 minus 12 over 4. So negative 25 minus 12, negative 37 over 4. How would I graph that? Again, just figure out what that is. Negative 37 over 4. 4 would go into negative 37 about 9 times, so a little bit more than 9. So should be right about there. So this is where the idea of symmetry can come in. Because I don't want to graph my x's, it just seems weird, I can say, well, I know that it's symmetrical. I know that it has to hit that y-intercept. So it's going to look something like this on one side. Considering that it's symmetrical, it's going to look the exact same on the other side. So I can actually graph these having only 2 points. So we asked for all of them, but I can graph them only having 2. So just real quick, find domain. I will do it down here. Range and min-max. So again, this has a min, I can tell, because it's got a stop point. And the minimum is at that negative 37 over 4. My domain, all quadratics are going to have the same domain because they all have the same shape. So they all are going to hit every single x value. My range, again, it has a stop point going down. It stops at negative 37 over 4, but it doesn't have a stop point going up, so it goes all the way up to infinity. So now, real quick, that work that we just did to find the axis, symmetry, and vertex seemed a little weird, right? There is actually a formula that you can use to find the axis, symmetry, and vertex. If you notice here, this is our negative b plus or minus that square root thing over the 2a. Like that's what we subbed in to get that x, right? So if we had averaged that, that square root thing would have just canceled out, right? Like that's what happened when we averaged these, the square root thing canceled out. So we would have been left with negative b plus negative b, so negative 2b. That's what our 5's were. Our 5's were our negative b over our 2a divided by 2, which is what, again, our 2a, our 2 was our 2a. And if I had simplified that, 2's would have canceled out. I would have had negative b over a divided by 2, which would be negative b over 2a. So if I do get something that's weird, and I'm not really sure how to find the vertex, I can use this formula. The axis of symmetry has a formula, a negative b over 2a. Since it's the axis of symmetry is the first coordinate of our vertex, that means our first coordinate of the vertex has a formula, negative b over 2a. It's just your first part of the quadratic formula. Okay.